Okay, so for this first video, we need to be able to look at a quadratic function and find this list of things just by looking at that and by looking at a graph. We need to find vertex, the axis of symmetry, concavity, minimum or maximum, and its domain or range. First of all, we know the equation we're going to use is y equals negative 2 x minus 3 squared plus 8. Just by looking at this, we can already tell that our vertex is going to be 3, 8 because vertex is equal to hk in this equation. And our axis of symmetry, or x equals h, would be 3. And the reason those are positive is because it's in the original equation, it's x minus h. So if you just plug in a positive, then it's still going to be x minus that positive number. It's going to concave down because the a, or negative 2, is less than 0. We know that this is going to be a maximum because a is less than 0. The question mark means that we don't know the maximum value yet, so we're going to find that. And we don't know the domain or range yet. Okay, so here I kind of made a table, but I didn't really plug in the numbers right. I just kind of gave you the numbers. So we plugged in 1, 2, and 3 for x, but we already knew that if we plugged in 3, that would give us just our 8, which is our vertex over there. So if we plug in 1, we got 0, and that's that point right there. We plug in 2, we get 6, and these are all being plugged into the y equals negative 2 x minus 3 squared plus 8 equation. So we plugged all those in and got our points. So, and this, because this is our vertex, and the x value in our vertex is a 3, we know that 3 is going to be our axis of symmetry. So now we're going to find the maximum value, which is basically the vertex, but I'm going to show you how to calculate that, I guess. First of all, we're starting with the equation y equals negative 2 x minus 3 squared plus 8. But we're gonna, so that's like what we've been using for the first portion of this video. But we're gonna put that in a standard form. I'm not gonna show you how to do that. I'm just gonna give it to you. So that's y equals negative 2x squared plus 12x minus 10. And we need to put this into y equals 2ax plus b, which is like finding our first derivative or something like that. So that's going to come out as y equals 2 times negative 2 because that's a. Our a is negative 2, x plus b, and our b is 12 because that's a, b, c. And then that's going to give us a value of y equals negative 4x plus 12. And then once we have y equals negative 4x plus 12, we're going to change the y into a 0. So it's like 0 property or something. So 0 equals negative 4x plus 12, subtract 12, and then divide that by negative 4. So all that, and then x is going to equal 3. And then we're going to plug that into our first equation. So it's going to be y equals negative 2 times 3 squared plus 12 times 3 minus 10, and our y is going to be equal to 8. So our maximum value of that equation is going to be 3, 8. So now we can find out the rest of our information. So here's the equation that we started with. We already were able to find the vertex, but I showed you like how to do that. So that was 3, 8. That's the point right here. Axis of symmetry, x equals 3 is right here. It's going to concave down, and again, the reason we know that is because our a is negative. It's like it's below 0. And we know that that's our maximum point. And instead of being minimum, if it were the minimum point, then the parabola would go like that. But instead it curves down. Our domain, which is kind of like our x values, it's all real numbers because if this just like kept going on and on, it would eventually reach all real numbers, right? And then our range, which is like y values, it's all numbers less than or equal to 8, because the maximum on this parabola only goes to positive 8, 5, 6, 7, 8. So this parabola can't possibly reach any point above that on the y-axis, right? So that is everything that you need to know.